classify the following numbers as rational or irrational with justification. We need to write some kind of justification end of it. So first thing first, root of 28 and root of 343. These are not your traditional prime factor form, is it not? So let's express the following in terms of prime factor form. So very first thing is root of 28, which is root of 4 into 7, which is root of 4 into root of 7, which is 2 root of 7. Why and how? A into b whole to the power of n is a to the power of n into b to the power of n. Okay, so with this we have root 4 being 2 root of 7, is it not? So I hope by now you guys are thorough with all of this. 343. So 343 is nothing but 7 cube, right? So this is 7 to the power of 3 root of that. This can be written as 7 to the power of 3 by 2, right? Because nth root of a to the power of m is a to the power of m by n. So this conversion you guys have to learn. So this can be written as actually I'm thinking of how best to move this forward, so that you guys are not confused. So this can be written as 7 to the power of 2 plus 1 by 2 and stuff like that, but okay, let me not do that. Okay guys, so this is your okay, let me do this whole cube. No, I think I'll just go with this because I want to give you guys the shortest version possible. So this is 3 by 2. Let's just keep this. So now you have the solution to be 2 into 7 by 2 divided by 7 to the power of half divided by 7 to the power of 3 by 2. This is 2 into 7 to the power of half minus 3 by 2. Agree? Or since the denominator is bigger, I can take it in this manner. So this is, how is this? A to the power of n by a to the power of m is 1 by a to the power of m minus n. Then the denominator is bigger than the numerator. Where is it? Yeah. Right guys. And for the simplification, we have 2 into 1 by 7 to the power of 3 by 2 minus half is 2 by 2, that is 7 to the power of 1. So 2 by 7. So what is the answer? It is a rational number since we have it's non-terminating but recurring. Okay. So since it's a non-terminating recurring number, it's not a irrational number. Okay guys. Yeah, we have few more problems. So the next one is clearly, we can't do much about this. 0.4, we don't have a root. Yes, we can simplify it a bit further. We can write it as square root of 4 by 10, right? Then it is negative 4 divided by negative 10. Reason being a by b whole to the power of n is a to the power of n by b to the power of n. We can do this. And we have the end of it, if I put this in brackets, minus 2 by root of 10. Okay. Yeah, it's not a standard way of writing stuff. We have to rationalize it, and end of it, you end up with this. So the point is, this is irrational. Justification, it is non-terminating, non-recurring. Here too we have root of 12, which can be written as root of 4 into 3, which is root of 4 into root of 3, which is 2 root of 3. So we have this to be not that, ab whole to the power of n is a to the power of n into b to the power of n. Next is root of 75 is equal to root of 25 into 3, is it not? So root of 25 into root of 3, again same reasoning, I'm not explaining the details. This is 5 root 3, and so we have the solution to be 2 root of 3 divided by 5 root of 3. So what is common? Root 3 is common, so we have 2 by 5. So this is rational numbers because it is terminating number. Okay guys, So next is this 1 plus root of 5 minus 4 minus 5. Why? See, the actual thing is, I'll explain it systematically. I open the brackets because let me do that also. See, minus of something, I'll write it as minus 1 into that particular expression. Minus of anything is we have to multiply with minus with both the terms. So I can open this bracket, plus 1 plus root of 5 minus 1 into this is minus 4 minus 1 into that is minus root of 5. Agree? So we have plus and minus root of 5 equal but opposite surds, opposite in terms of sign, that is. So this will get cancelled and we have minus 3. So in all of this we have terminating numbers. So in this two, not all of this two, we have terminating numbers. So it is what? It is rational number, right guys? Terminating is rational number. And in one of this we have irrational number, and here it is non-terminating but recurring, so it is rational. So only one irrational we have found. This is okay. You can clearly see there is a repetition, 10.1241. So this is what? Non-terminating but recurring, so it is rational. Agree? So that's the justification you guys can give. Here there is a pattern, but again you can see that the pattern is not the one which we look for. It's a different pattern. Yes, there is a pattern, I agree, but not the one which satisfies it being a non-terminating but recurring. So this is irrational. Okay, so here it is not, it's a non-terminating and non-recurring. That's all your justification is. You just have to phrase it this way: non-terminating, non-recurring. If not non-terminating, recurring. If not, it's terminating. Okay, that is your justification as well. So yeah, okay guys, it's a good revision. I hope you guys are thorough with your roots and exponents and everything, because once we are done with this chapter, I'm already a bit faster than what I started with, so I'll continue to be fast.